Afternoon. Welcome to Does Dropping USB Drives Really Work in Mendeley EF by Ellie Burstein. Before we begin, a few brief notes. Stop by the business hall located in Bayside AB during the day and for the welcome reception from 1730 to 1900 tonight. Also, the Black Hat Arsenal is on the Palm Foyer on level 3. Finally, join us for the Pawnee Awards tonight at Mendeley BCD, which is right next door, at 1630. Thanks for putting your phone on vibrate. It makes it easier for the rest of us to ignore the ringing while you wait for your voicemail to pick it up. Finally, there are microphones interspersed throughout the floor. When it comes to the Q&A, we would really appreciate it if you would make use of those since we are recording. With that, Ellie.
Bonjour, my name is Ellie Burstein, and today, as you see, I'm going to tell you a little bit about the result of our large-scale study we did about how effective are USB drop attack. This is something I did on my spare time with my co-conspirators from the University of Michigan and the University of Illinois. During my day job, I work at Google, where I lead the anti-fraud and abuse research team. So it's a little known secret in our community that dropping USB key in parking lot and other weird places work. I can't remember a single Black Hat, and I've been to many, where I couldn't remember, someone told me, I drop a USB key and boom, magic, I got the job done. And it becomes such a well-known secret that last year, a TV show decided to feature it in one of their episodes. Do you guys can figure out which one it is? Yes, you're all correct. Mr. Robot did feature USB drop attack in their episode 6 last year. Love the TV show. So that begs the question, does dropping USB key really work? Is it a fluke, or is it like really the real thing and we should all do that and go out on vacation and not rely on super complex attacks, right? So to answer this question, today I'm going to go through three main points. The first one is we're going to briefly review what are the three types of attacks that you can have with the USB keys. Next, we're going to discuss how effective are USB drop attacks. This is a result of our large-scale study where we dropped 297 keys. And yes, that's a lot of keys. And finally, we're going to think about how an attacker can push forward based on what we did and do it more efficiently and really make use of those USB drop attacks. So let's start with reviewing what are the type of attacks you can carry through USB. So it's mainly three types of attack. The first one is a social engineering attack where you try to convince people to either click on the link or directly phish them for the login and password. Then you have the HID spoofing, which is human interface devices where you use custom hardware to emulate a keyboard. And finally, there is the fabled and yet never seen zero-day USB key who will exploit a bug into one of the drivers. So the social engineering attack is very simple. You take a USB key, any key will do. You put a bunch of phishing HTML file, you name them confidential, secret, do not open, it's pretty good. And then you hope that people will click on them and then okay. And the next one is the HID, so human interface device spoofing attacks, where you basically have a custom hardware which will pretend to be a keyboard, and as a result will be actually viewed by the operating system as a keyboard. This keyboard is programmed to inject a bunch of keystrokes which will result in a bunch of commands which will compromise the victim computer. So the end goal is, of course, to get a remote shell which connects back to the attacker, and then you get full control over the computer. So what are the pros and cons of those three types of attack? The social engineering attack, which is the one we use in our study, is very easy to do. You basically create a bunch of HTML files. It's very not reliable because you're not only counting on the people to plug the key, but also to fall for the idea to click on the HTML file, which have a weird name. And it's not very stealth at all because you obviously have the user to see a bunch of files and he can open them and look at the source code, so it's not stealth at all. On the plus side, it is extremely cross-platform because every OSs do know how to open an HTML file. The HID spoofing attack, which is probably used by pen tester and corporate espionage most likely, is a little bit more complex to carry out because you have to have custom hardware that you need to program, usually in C. Then it's a little bit more reliable because as soon as you plug the key, and I'll show you a demo, the computer is compromised, It's not that stealth because you see a bunch of terminal popping in, popping out, and it do weird things, so you might be surprised about it, but it's more stealth than the social engineering one because after the attack is carried, there is nothing left to see. And it's not really cross-OS because each operating system requires you a different type of command. The last one, fabled zero-day attack, is extremely complex to carry out because you have to find a bug, you have to write the code to exploit it, and you have to bake it into a custom hardware. It is extremely reliable for the operating system and version you are targeting, I believe. And it's stealth because you don't see anything. It's all happened at the driver level, so there's nothing to see. It's absolutely not cross-OS because you have to find one bug for each OS, or more likely each OS and each driver version. So how effective are USB drop attacks? To answer this question, I had a very complex game plan that you can see. Let's just drop a ton of USB key and see what happens. So this is not as easy as you would imagine because we had to jump to a few hoops to get to approval for that. So the first thing was we had to go to the university and say, hey, we would like to bring MIAM to your campus. Would be okay with that? They're like, we don't know. How about you make it sure you only use regular key with plain HTML file? So we had to resort to the social engineering attack because they were concerned about us arming the people who plug the key. The second thing is we had to work with public safety and tell them, well, something weird might happen at a moment notice, so don't worry about it, it's all fine, it's just an experiment. But all in all, we were able to get the internal review board, the university council, and public safety on board to the idea of dropping all those keys during 2 days on the Illinois campus. The second thing is we have it's not that easy to manage and trace 297 keys, so we had to build a full framework to actually track them, hitting them, to monitoring them, to know where they've been dropped so we can actually have all the data. And finally, we added a debrief to help understand why the hell people did click on them, if any of them would do that. So here's basically what our framework looked like. The first thing we wrote is a simple Python script who will create a key and assign to it, create a file, and assign to each of the file, inside the file, a unique identifier which helps us to trace the life cycle of the key. Upon creation, it registers the key to a server, which is set on Google App Engine, and then we wrote a small Android app that would be used by the dropper. We had many undergrad and grad students help us dropping the key. You need a lot of manpower to drop 300 keys. And this app will record the location, the type of the drop, and where the type of location it was, so we can trace location of the drop. And finally, when you would open one of the HTML files, the HTML file will embed an images. These images had a unique identifier, and this unique identifier would help you to trace which one were open. Optionally, people had the option instead, in exchange of an Amazon gift card, to answer a survey about how much they knew about security and why did they decided to open the USB key. So we try to understand a little bit of the mindset of someone who would open such a key. So we tried to control for a bunch of ideas. Like we were curious about to know first, is the key appearances will be impacting in one way or another the opening rate. So we started with a simple swivel key. We had multiple colors of those. And then we say, okay, let's try to add real keys to it. Maybe people will fall for it because if there is a real key, maybe it's more important. Then we're like, okay, let's add a return label with the name of the experiment and see if people actually return the key to us. Then we're like, okay, let's make it more interesting. How about we put a label on it? So we try confidential. And I'm not saying student are cheater, but we thought that final exam answer might be useful. So that's our 5 types of keys. And for each key, we went through the trouble to personalize the content. So this is basically a view of the file we had. So it was the one who had no label. We had a bunch of documents like resume, basically photos and so forth. So we tried to figure out what people would open. Would they try to open photo? Would they try to open a resume? Would they try to open a doc? That was an interesting social experiment. The other thing we did is for the final exam, we had a bunch of final exam naming and then try to see if people would open those. And finally, for the confidential one, we tried a bunch of ideas, including termination letters, confidential, meeting notes, and try to see which one people would open. So we also wanted to control about drop location. So the first one, the obvious one, is parking lot. Does it work on parking lot? But how about just outside? On a bench, for example, would that work? We also were is it more impactful when you are inside the building? So we drop it into the common room. We drop it into the classroom. Apparently, one of our students got caught doing it, but And then finally, we also drop it into the hallway. And so we get an idea of whether inside versus outside of the building, where you are probably more confident that you are safe, will impact the opening rate, right? So that's what we did. Here's a few shots from the app. So this is a parking lot drop, a real one, and you can see it. The USB key at the bottom. We had outside on the table, and outside on a bench, which is for the bus stop. And so that's, for example, one of the 3 drops we did of the 300. I will show you 300 photos, but it's going boring very quickly. So here's a better view. This is the overview of where we drop key. We try to cover all the campus. And as I said, we do it through 2 days and 2 waves. And we drop it all over the place to see if it also would affect the thing. So after all this hard work, what happened? Well, the first thing is we got busted. This is a Reddit thread. We're like, hey, I don't know what happened. I found the final exam answer on the campus. This guy is very honest. Anyway, and then the guy replied, yeah, don't worry about it. It's a study. No, everything is fine. It was actually 24 hours before we started, so it tells you how long it takes to people to catch up. So basically, within the first few hours, no one noticed it. It actually took a while, and again, it's 300 keys, so it's really, really visible. So after all of this, main question, right? Did it work? Yeah, so 45% of the people not only plugged the key, but as I mentioned, also decided to click on the file. Yep. So let's recap a little bit what the study is in number. So we dropped 297 keys. We tried 300, but 3 failed. That's why the 97 comes in play. Of those, 290 were picked up. So at least we made quite a few people happy with the new USB key. Of those, 135 did phone home. That's roughly 45.5%. And then we got 54 keys back. Thank you to the people who bring them back. We actually kindly asked them to keep them. So if you were to open the file, we say this is part of an experiment. You're welcome to keep the key. But a lot of people felt that they wanted to return the key. So 54 people did return us the key. And we got 62 people, which is 21%, who actually answered the survey, which is quite an interesting number because it gives us enough sample to really understand what happened. So the first thing to look at is how fast our keys were open. So 20% of our keys were open within the first hour, which is really fast. And 50% were open in less than 5 hours. So not only USB drop key work, but it is also very fast and it's also very fast. We were actually surprised by the speed of the opening rate. The other thing we try to do, remember, is try to figure out, is there any correlation between the appearance of the key and the opening rate? It turns out that it's not statistically significant. While the number is a little bit different, we don't have enough sample to do any significant conclusion, but you can see that one thing is significant, so do not put return label. I don't know why you would do that if you are an attacker, to put your name on the key, but don't do it, it doesn't work. People will not open it, they will just bring it back to you. Probably not what you want. The other thing is we try to control of, is there any differences for the drop location? And again, not much differences. The parking lot still to appear a little bit higher, but again, it is not statistically significant, but yes, parking lot seems to work, so we proved. So legends are real. Yes, you can drop USB key on the parking lot, and yes, Mr. Robot, once again, did a realistic thing. Kudos to them. Outside work as well, and everything works almost the same way, so no reason to plant them outside of the parking lot. That seems the best place to be. Why people did open those damn keys? Well, a lot of people say, oh, I wanted to open the file so I know who it was, so I can return the key. Benevolent was the main reason why people wanted to open the key. 18% say, well, I was just curious, and others had other motives. Now, what's interesting is I know which files they opened. You remember? I had a bunch of interesting files, right? How many people of you bet it actually matched what they said? No one raised their hand. Come on. Such a low expectation of a fellow human being. Well, you're right. Yes, you're right. Most of the people were opening pictures, not really resume or other document. They just like, yes, let's go for the picture because you know everyone on the 5,000 people campus. That's the best way to find who the person is. So yes, surprisingly, the behavior do not match the intent. I do believe that people would still want to return the key. And as I said, we had 54 key return, but it's interesting to see that photo was the most open one. So that's where we stopped as a study, right? We can't hack people, but that's not what an attacker would do, right? An attacker would not use social engineering keys. They would use more advanced key because they want to assure fire. And now I'm going to talk to you about how, as a pen tester or as an attacker, you would go about dropping keys which are way better in the opening rate, right? Remember, we have 45% who plugged and clicked on the file, but there's probably a higher number who plugged and didn't click on the file. So how do you get those extra percentage if you're an attacker and you actually really want to compromise people? Well, first, let me show you a demo of what we're going to go and build. So there is a key on the stairs, and you're very curious, so you pick up the key, like, oh, it seems interesting. How about I plug it into my computer? And so you go home, and I'm like, hey, I'm going to see what happened to it. And then I plug it. Yeah, I'm not really good at plugging USB key. And then nothing happened really, and then my computer starts to act strange. It makes noise, and you can't hear the noise, but then it starts to see weird command are opening. It starts to open a terminal by its own light, and then code happen, and then the computer is compromised. That's all you see as a victim. That's how fast it is, that's how deadly it is. This is what you see from the server side. I use Metasploit because that's all you need to really do it. And you see now I have a interactive session, which is a remote share to the computer, and then you can ask who I am. Of course, it was a test, so the user is test. You can do ls, you can do whatever you want. So basically, it takes literally 2-second plug to get compromised, and you can open a web page, make the computer do stupid things. That's what a USB drop attack will look like in real life. That's how reliable and fast it is. So the moment the terminal opens, you're dead because you can't even have fast enough to close it. That's what's going to happen. So now, let me tell you how you do that. So the first thing is, I want to point out is HID, Human Interface Device Spoofing, is not new. I remember a talk by Adrian in DEF CON 10 in 2010 showing us one of those early HID devices, which is on the picture. The only problem with it is I don't think anyone will plug that. Sami Kamkar did a very nice one for his necklace for OS X. Again, I won't plug that, but it was interesting that it worked both for Windows or OS X. It's one or the other at that point. And we have a problem of making it realistic, right? So it's not that technology doesn't exist, it's like we just have to reshape it to make it work for our use case. So that's what we're going to do. So here's the challenge when you try to weaponize HID device for making them droppable. The first thing is you have to make them cross-device. It turns out that HID devices are never meant to have any feedback from the operating system because they are OS agnostic. So you have to find a way to fingerprint whether you are on OS X or Windows or even Linux, because there is no way to know where you're going to plug the key. If you're a pen tester, you know your environment, so you can plug the key and it do things fast for you. But in our case, it's going to be dropped. Will the guy plug it on the Mac? On the Windows, we don't know. So the key has to figure it out itself what to do. The second thing is you have to create a small binary persistent reverse shell. You have to be small payload because keyboard don't type very fast, and it has to be only script to not trigger AV, and we do a reverse shell to bypass firewall. Finally, and the most fun part of the project, and I'll show you a ton of photo in a bit, is how to make them realistic. I have them here, by the way, so after the talk, if you're welcome to come on stage and look at all the stages, I brought them for me so you can feel how real they feel. So how we do that? How we overcome this? So we start with a very, very tiny devices, which is a TNC, and it's very small. So we know it's going to fit well into a fake USB key. It's programmable in C, and it's Arduino compatible, and that's what most of people use for their previous work. So, okay, wrong button. Play. Okay. So how do you craft a payload for that? The first thing we need to figure out is when the drivers are loaded. So The first thing is when you plug the key, we don't know how long it's going to take for the key to load because of the system have different timing. The second thing is we need, as I said, to fingerprint which OS it will be. And finally, we have to execute the reverse shell. So a few gotcha. The first thing is the timing between the command. Usual previous work were relying on careful crafted timing. The problem here is the timing are different between one OS to another, so we have to be careful about that. And the second one is it's really complex to know if you have successfully executed your command because, again, no direct feedback into an HID device. The way we go about that is by using the caps lock key. So the caps lock key, you can turn it on or off, and actually the keyboard knows about it. So basically the idea is you try to issue a toggle, execute your command, toggle it back, and check if it changed. Until it has changed, you know your command haven't been executed because it waits for it. And so this idea is using a 1-bit feedback based on the key status. So the reason why you use caps lock is, and I spent quite a bit of time trying to debug that, is there is no num-scroll key on OS X. I don't understand why my stuff was not working. Like, oh, okay, it's just the key did not exist, so the OS does not know how to turn it on and off. So basically, it's how you implement it in C. The code is available, by the way, on GitHub. I made it available today if you're interested. But the basic idea is we try to make it, to test the loading devices, we try to blink it because it has an internal LED, and then we be able to blink, we know it's loaded, and then we try to execute our attack. For the fingerprint, there was a work 2 years ago presented at Black Hat about USB fingerprinting, and I was about to implement that. It seemed very, very complex for what I wanted. When Jean-Michel, my friend, came up with the idea that we can probably try to lock, to do a lock, the scroll lock key in PowerShell, and if it was working, then we will be on Windows, and also will be on OS X or Linux. And it turned out it works really well, and it's very flexible because you can do way more with this technique, so we implemented this one instead, and it proved very, very reliable in many, many devices we tested, so we stuck with this one to fingerprint which OS it is. So how do you spawn a reverse shell? So the last stage is spawning the reverse shell. The first thing is you open a terminal, then you spawn a process because you want it as a background process. You don't want it as a foreground process because people can kill it. A lot of previous work were just opening a terminal, but people would close it. What I do is I spawn a background process, and then in this background process, I run a reverse TCP connection back to the server, which in our case is Metasploit because it already do an awesome job as being a command and control, and there is no code needed on that stage. A few things to note is we do a reverse shell because we want to pierce through firewall. You have no idea what the firewall would look like, so you want to connect back, which is usually more hollow than inbound connection. We use scripting language and obfuscation because we want to avoid antivirus. We also do it only in memory and not touching the disk for the same reason. The payload has to be small. In certain OSs, you probably don't know it, but there's only 62 keystrokes per second. So your payload has to be super, super tiny, otherwise it's going to take like ages for it to type. So there is no way you're going to type a full binary in a terminal. That's not going to work for you. And finally, as I said, we leverage Metasploit as a command and control because there is no way we're going to reinvent the wheel if something is doing a great job at it. So the macOS 6 payload was actually surprisingly small. I was about to write it in Python, and then I came across this cheat sheet from Pentest Monkey, who has this one-line reverse shell in Bash with an unknown functionality I never knew about it, which basically opened a TCP connection in Bash. So all I had to do is put it into a background process, and then we were done. And we end up with a 100-character reverse shell, I believe, which actually resides in background, will reconnect, will do everything you want, 100 characters. This is super tiny, works perfectly well. Saves me a ton of time. On Windows, it's more complicated. So I took inspiration from PowerFun by Ben Turner and Dave Hardy. And so the idea is to create a TCP connection in PowerShell which connects back to the server. Then we're going to take this payload, compress it so it's smaller, and then base 64 it so we can put it as, make it typeable by the TNC, and we put it into an outer payload which will basically use, again, PowerShell to spawn a process, decode it, decompress it, and execute it in memory, and you would end up again with a reverse shell in memory. So that's how the TNC I have program work both on Windows and on OS X. The code is available on GitHub. There will be a link at the end of the talk, so you can download it, look at it, improve it. If you have improvement, please commit. Send me a commit. I will gladly take it. So the fun part, how do you make this thing, which doesn't look like at all like a USB? So first step, we have a TNC, And then, well, you can plug an adapter, but that doesn't look like a USB key at all. So the first thing you have to do is, okay, can't use an adapter. We have to order a Type A connector, and then I'm going to solder it like this. And then by soldering it, we have almost a USB key in terms of size, right? It's the right step in the right direction. Now we have, it seems the right size, it seems okay. It takes a little bit of practice. This is my early experiment, not that great. On the right side is also me trying to remove the micro USB because the first time I didn't know you can leave it up. So I actually ended up breaking a TNC. So, but after a few practice, you get the hang of it, and then we were able to make 10 of those. So practice make it perfect. And then you have to create a silicone mold. And so the way you create silicone mold is you order a bunch of silicone, you mix it until you have a nice goo, and then you take the key. So in my example, it's this one. So it's a normal USB key. I bought it, and then I basically put a clamp on it, put it into a plastic cup, and then I pour the silicone into the cup. The only gotcha here is silicone has air. So if you don't want to have bubble and you don't have your key have a very sleek aspect, you have to be careful to remove the air. The way you would do that is either by vacuuming the key, or if you don't have a vacuum like us, you actually need to pour it from very high up, and then it will have a thin stream of silicone would remove the air. And so basically you let it rest for 24 hours, and then you get a mold like this one, and it's very squishy, and the mold will be used to cast the key. So how you go about casting a key? So the idea here is we're going to use resin, and we're going to colorize it. And so the resin is two polymers you're going to mix. So one thing here to note is you can't mix all of it at once because it's going to very quickly solidify. So what you do is you use two syringes, one for each product, and you use about 10 cc of each. And you mix them, and you take 2 cc of colors, and then you mix all of this, and you obtain your resin, and then you're going to cast it. Do wear a glove, do wear a lab coat if you attempt to do that because it's extremely toxic to have it on your skin, so be careful. By the way, this is actual photo of us doing it, so we documented everything. And so basically then you pour your resin into the mold and you overflow it almost, and then you stick the TNC into it and you let it rest. If you're too impatient, you're going to break it, so leave it about 30 minutes. And then you're going to open up with something like this. Yes, that's a cast TNC, and it looks really, really almost like the same thing. And the excess resin is really easy to remove with a small knife. It's not hard, so don't worry about excess resin. It's better to have too much than not enough. The only other gotcha we had is do not let it overflow to the hole into the connector, otherwise your USB key ends up to not work. And it's really hard to remove, actually, when it's inside the connector. And so, well, the first attempt was not that great. Too impatient, no colors, and, well, we were almost there. And then we got this advice that you need to use lubricant to make sure that you can remove really easily the key out of the mold, except it gives you this really bad look, like it's a smudge, and it's not like a smudge you can remove, it's just literally in the key. It's here if people want to see it. And so do not use lubricant. But then you try it again and again, and then at the end of the day, here's what you obtain. It almost look perfect, right? No? Yes? No applause? No? Okay. But a lot of work. It took us like a full week. It literally took a full week to get all this experiment, and we were at it every night, like 4 or 5 hours at a time. But yeah, you really obtain like USB key, which like the real thing. The only thing you might notice is the connector is a little bit off center because of where the TNC soldering is. But other than that, it literally looks like the real thing. And so how much does that cost? Well, it costs about $40 to actually make such a key. It costs about $20 to get the TNC. The mold and resin casting is about $10, and the equipment and supply is about $10 as well. So in total, you're going to end up with paying $40 for a key. Not cheap change, but absolutely doable for someone who really wants to make it work. And this is a price assuming you're actually making 10 keys and you already have all the equipment to do it. There is a lazy approach you can try as well if you don't want to do that, is you take a key which has a rubberized aspect, and then you remove the inner working of it, and then you pour directly your resin inside the mold, and then you plug your TNT like we did in a Voyager key, and then you obtain a key. It doesn't look as sleek, I think, and it's a little bit weird, but it's just definitely a shortcut. The last thing I wanted to discuss is how do you defend against those attacks? The first thing you can do is awareness and security training. I think that's the most important thing. That's why I wrote so many blog posts about it, is teaching people to be mindful of what they plug in their computer. Try to tell them that you do not pick up food from the floor, so you probably should not pick up a USB key from the floor. You might also get poisoned by it. If you're in a company, you can absolutely block the port. You can plug the USB port, and that's only available. And the last thing is, and it's like kind of a band-aid, you can use Windows policy to disable certain type of device, or you can use a code which is called USB key, which will basically reboot your computer if a specific type of device is plugged or a known device. The problem with that is the USB protocol do not have authentication. So as a result, anyone can appear to be like a Microsoft keyboard or a Logitech keyboard. So it's not a sure thing. And that's what deterred me to write one more of those, because it's a false sense of security. People will be able to spoof any IDs they want. So if they know you have a Logitech keyboard, well, there would be a Logitech keyboard and it won't work. So the takeaway. First, legend proved USB drop attacks do work, and we found at least 45% of people did click. And then you can actually create reliable malicious USB key. It's not trivial, but for someone who really wants to do it, they can. It requires a bit of handy work. And finally, yes, there is no easy defense, which also explains why it's such a deadly attack. But in that case, device policy and awareness is something which would help mitigate that kind of attacks, like any social engineering attacks. I would like to thank a lot of people, because all you saw looked like really easy, but in reality there was a lot of people helping us. Silty, who work on the silicone molding and casting with me, Nicola Pixel Noble, who helped us with the hardware soldering, teaching me how to not mess up with my TNC, Jean-Michel Picot, who invented the idea of the fingerprint and helped with the TNC programming, Michael Bailey, who is my co-conspirator from the University of Illinois, who convinced the university to let us drop all the key, Zakir and Matt Trisher, who were the students who actually did all the heavy lifting of dropping the key while having coffee. And so, if you want to build one, I just put online a blog post who details everything I just told you. You can step by step, from writing the payload to creating your own mold to creating your own fake USB. It's really easy to do. The code is on GitHub. If you want a free one, I have about 8 left. And I'm pretty sure there is more people who want them than I can give. So if you just research the blog post, I know you're interested, and then when I'm coming back to San Francisco Monday, I will pick a few people and will just mail them to you. And don't worry, the payload is absolutely innocuous. Don't worry, you can absolutely plug it. So the other thing we came to mind when we were working on this project was the idea that we might create more advanced HID key. We haven't just get to the bottom of it. We can probably imagine something which bridge air gap with a GSM and Wi-Fi exfiltration module, have hardware-based fingerprint and so forth. That being said, that we need a lot of people who are interested in having those keys. So if you are, please let me know. And then if we have enough people, we'll probably do a Kickstarter and we'll try to build those. So thank you very much for attending the talk. I know it was a short talk, but I hope you liked it. I will take questions. I also wanted to let a few minutes for people to come on stage and see the key by themselves if you are interested. So that's why it was so short. Don't forget to fill out your questionnaire. They're going to give an award, and it's for us to do it. So please, if you're happy with the talk, let them know. I will know as well. Thank you very much.